Hello everyone, welcome to my channel. In this video, we will be looking into analysis and design of box culvert. First of all, we will go through all the manual calculations that need to be done. Then once that is done, we will move into SCIA Engineer to model the box culvert and design it. Let's assume for this case, we have a box culvert of 1.5 meter height by 1.5 meter width. This particular box culvert, initially we will be assuming a thickness of 150 mm, and the data that we will be taking initially will be unit weight as 20 kilonewton per meter square, angle of internal friction as 30°, and let's assume a live load of 100 kilonewton per meter square on it. Basically, live load, as per the different codes, there are different kinds of loadings like the different kinds of rolling loads we need to apply, and based on that maximum one we take, but we will not be considering that as of now in this particular video, because here the main agenda is to see the main parameters, the main manual calculations, and how to model it in SCIA Engineer and design it. So, I mean, based on the earth pressure, like as it will be retaining some soil on the sides of the wall, there will be some earth pressure which will be triangular in shape. Plus, because of the live load, there will be some lateral thrust that will be rectangular along the depth. So, this is how the load distribution will look like that we will be applying into SCIA Engineer for this case. Now, the question that might come into the minds of students is like, if we are applying the pressure vertically, then how to convert it laterally? We use coefficients for that. There is an active earth coefficient, passive earth coefficient, and coefficient at rest. I have explained already all these three kinds of coefficients in my earlier video. I'll drop a link here in this video. You can have a look into it, and you will be cleared with this concept. So, I mean, if there is any kind of pressure which is acting vertically, and if there is some structure which is retaining that particular soil, then in order to apply the lateral load on that particular structure, we use the coefficients, which are nothing but active earth coefficient, passive earth coefficient, and coefficient at rest. Now, the next question which will come, when to use what? So, basically, when there is no scope of movement to the wall, we use coefficient at rest. When there is a scope for a wall to move, we use either active or passive. Active can be used in such cases where the wall is moving away from the backfill, and passive can be used in such cases where wall is moving towards the backfill. Now the question will come, like, what are the practical cases where this condition actually happens? So we can just assume the box culvert case here only. Like in case of the box culvert, the top slab is restraining the side walls to move inside. So it is remaining at its rest condition. So because of that, there is no scope of the movement of this wall. And because of that, we need to consider the coefficient at rest for this particular case. Now let's assume there is a retaining wall and there is a loading which is acting from one side. Because of this loading, the wall will move away from the backfill. Now it is having the scope to move away from the wall. In this condition, we will use active earth coefficient. Now, let's assume there is a basement wall which is retaining some soil on one side and there is a parking on other side. So because of this load on the parking, there will be some passive pressure exerted on the other side. So in that case, on one side we will be using active earth coefficient, and on other side we will be using passive earth coefficient. I hope these concepts are clear to you now. We will move to the next thing, which is calculations of the load. As we know, this is a box culvert. We will be using coefficient at rest. So for coefficient at rest, at angle of internal friction 30 degree, we get that coefficient as 0.5. If you want to know how we calculate these coefficients, you can visit my earlier videos. And after that, as we all know, gamma into h, unit weight multiplied by the height of backfill, multiplied by your coefficient of earth pressure, you get the pressure. So we already have the earth pressure at the base, which is 15 kilonewton per meter square. And also for the live load, in order to convert that vertical live load into lateral, we will multiply it with the coefficient and we will get the lateral load due to live load will be 50 kilonewton per meter square. Now we will move into SCIA Engineer in order to see how we model there and how we do the analysis for the same. So let me just show you the screen. Yep. So here I'll just create a new file for you guys, just in order to show you from start, like how we exactly do the modeling. So once you do new, let's give it some name. I'll give it a name, let's say box culvert. We can select the material as concrete. Then we can just go to unit set. Let's keep metric format only as of now. I'll click on OK. After that, the first step that we need to do is create the grid. We will go to line grid and story, 3D line grid. Once we do that, you will get some interface like this. As we know, we are having a culvert of 1.5 meter by 1.5 meter. I'll keep the space in y direction as 1 meter as we are doing per meter calculations. I'll click on OK. Once this is done, I'll set this particular grid at the global coordinate axis and I'll escape. Once this is done, the next step for us is to go to main, go to structures, go to 2D members, plates, then click on plate. After that, you can just give the thickness for which you want to iterate initially. As of now, as we have taken 150 mm, so I'm keeping that thickness. I'll click OK. Now we will create this particular plates. Okay. Once you are done with creation of the plates, you can just switch on the render geometry in order to see how your box culvert is modeled. And if any error or something like that, that will be visible. After that, I'll just try to check the orientations of my local axis. So in case of box culvert in SCIA, the thumb rule that I follow for local axis is I always try to orient the local z axis outwards and the for the base inwards. And also I try to keep all the red and green local axis aligned with each other. So in order to do that, here it's inside as of now. So I'll just click on this particular shell. There is an option here of swapping the orientation. I'll just click yes. So it will just swap the orientation. After that, I'll try to check if all the green local axis of all the plates are in one direction. As of now, I can see these two are in one direction, but this isn't. So I'll just click on the shell. Now there is an option of LCS angle. I'll just rotate it by 90 degrees. For the bottom plate, I can see the green axis is not in alignment with this particular three shells. So I'll do the similar thing for the bottom one also. I'll just rotate it. Now it looks good. Once this is done, you can switch off the local axis. After that, the next step is to create the load cases. As we have already seen in the step of manual calculations, we need to create two load cases, one for earth pressure. Description, I'll just keep EP. And the next one will be for live load. I'll just add description as LL. Once this is done, I'll close this. Then I'll create combinations for which we need to check the design. I'll keep the type as envelope ultimate. Or let's keep it as linear ultimate. Linear ultimate is simply the addition of all the load cases. And the load case for which I need to check, I want to check this for a combination of 1.5 load factor for all the cases. I'll click OK and I'll close this. Once this is done, now you have to assign the loads for which you have created the load combinations for the load cases. So I'll go to this load. Once I click on load, on the top, you will see this drop down. It will show you which particular load cases you have. So initially, let's say I want to assign live load. I'll just click on live load. You can go to surface load for the same. If there are uniform loads that you need to apply, you can directly choose this particular option on 2D members. Once you click here, as we know, we are having a live load of around 100 kilonewton per meter square. So I'll click OK. I'll assign on this particular member. So once you just click the particular shell and escape, it will assign the load. After that, we know there are also some lateral loads acting because of the live load laterally. So what we will be doing for that, we will be also selecting the 2D members for it. And that load is 50 kilonewton per meter square. So again, selecting this option, minus 50, assign. Okay. We have assigned the live loads. Now we will go to earth pressure. As we know, the distribution of earth pressure is triangular as per the depth. So we will need to select this free option. Before that, first of all, we will need to bring our axis in plane of the particular plate where we need to apply the load. For that, what we will do, we will go to Tools, UCS, and then we will select this option of vertical orthogonal to X. I'll just select here. After that, I'll click on free. I'll keep the direction as Z because Z is the direction in which we need to apply the load. Distribution, I'll keep along Y. As we know, the load is varying from 0 to minus 15. Then we need to assign the members as per the assign the loads as per the member LCS. So we will select this option. We will keep these things as a setup for this and we'll click OK. After this is done, it will ask us to select the particular plate on which you need to apply the load. So we will just apply this load on this particular shell and we'll escape. Now you can see it has already applied a triangular kind of a distribution on these plates. I'll do generate the loads, so it will apply the loads on both sides. Once this is done, the next step is to assign the supports on the base. For this, we will go to structures. Then we will go to model data, supports on foundation. Now let's assume for this case we are having some slightly silty kind of a soil which is very steep and something like a gravel. So we will just copy this to our project and we will close it. Now we have we have taken this particular soil properties, but for this particular soil properties, there are no spring values in X and Y. We will consider at least 10% in X and Y for this case. So as it is 35, so it will be 3.5 in X and Y. And I'll just click OK. Now it will ask for the plate on which you need to assign this particular support. So I'll just click it here and escape. We have modeled the culvert. We have assigned all the loads. We have assigned all the supports. Now we will again go to main. Then we will go to calculation mesh. Then we will go to calculation. Here I always follow a thumb rule. If I'm having a thickness of somewhere around 150, I always try to create the mesh at thickness divided by 2. So for us, it will be at 0.075 for this case. And I'll just click on calculate. Once this is done, by the way, this is the first step for iteration. You can keep on reducing the size of the mesh until and unless you get the similar results. That's what the convergence of the particular results happens. So once this is done, I'll click on OK. I'll go to results. Then the main result that we need to check in case of culvert is bending moments, for which we need to give the reinforcements. And how you can check the bending moments, you can just go to 2D members, internal forces. After that, there will be a property window which will appear on the right hand side. Here you can select the type of load. Here I will create the combination and select the combination, and in that combination I'll select linear ultimate. In linear ultimate, I'll just do averaging at peaks. And after doing that, you will see it will show the value of moment in X. So I'll just refresh and you will be able to see the moment contour plots on our particular shell. Now, this is the beauty of aligning the local axis with respect to each other. You can see the results for this particular plate is completely in resonance with particular shell. So this helps to interpret the results. Now this is the moment in X direction for our case. Now I'll do My. So this will show the moment in Y direction. So this is the way you can check the moments. Now the next step is to calculate the moment resisting capacity with respect to the particular thickness that you are using. As per the IS 456 and Indian codes, we know if we are using a grade of FE 500, how you calculate the moment of resistance. This should be MR, by the way. So moment of resistance is 0.132 FCK into BD square. This is a particular value when your section is a balanced one. If you want to know under reinforce, over reinforce and balance section, I have already prepared a video on it. You can have a look at that in order to clear your concepts. Once you do it, it will show you what's the capacity of your movement that you are getting for this particular value. And you can equate this particular moment of resistance with your equation with respect to force in tension side multiplied by lever arm to get the area of tensile steel that is required for this particular moment. So now the ultimate thing that we need from this particular calculation is what is your moment of resistance capacity. Once you get that, you can again go to SCIA. After going to SCIA, there is an option here of drawing setup 2D. You can click on these three dots, minimum maximum settings, user defined values. You can click this option, and here just give the value of your capacities. Let's say as I'm having -90 to +90. I'll select the style as extreme only. The negative extreme I'll select as red, positive extreme I'll select as blue. I'll click on OK and I'll refresh. So what we have done, we have set a particular limits into this particular plot. If the moment values from the analysis goes above those limits, it will show some colors. As we can see, no moment is going above -90 as well as +90. This means whatever the capacity that we are using for our section is completely safe to give. So now this is for MY. We can check this for MX also. So it is showing no colors. Now I also want to show you how the colors actually looks like in SCIA if the capacity exceeds the particular analysis values. So let's say if I click here -19 and if I go to +19 and if I just click OK, refresh. In MX, it's not exceeding. Let's see MY. So yep, now you can see these are the particular portions where the capacity is getting exceeded and we need to increase the reinforcements in this particular side or increase the thickness and optimize. So this is how you use SCIA Engineer in order to do the analysis and design. Ping me in the comment box if you need to know more about SCIA Engineer or any other topic that you want to learn in depth, and I would happy to help you. Thank you. Thanks a lot.